Okay, so with 9-4, we are on to our third shape of conic sections. We've done parabolas, we've done circles, now we're doing ellipses, and then the only one left will be hyperbolas, and that's coming up next. So I'm not going to give you guys like an actual official definition of an ellipse. It's in the book. I'll read it off for you. It's very strange. It says, an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points is constant. So it's a very strange definition. Because you know the way the circle works is that every point in the circle is the same distance from the center. This is a similar sort of idea, but if you look there are two different types of ellipses that we could see. So I just want you guys to label them. So this one right here, this we call the horizontal ellipse. And the only reason that we refer to it as horizontal is just because it's wider in a horizontal direction. And then this one we refer to as the vertical one, and again, that's just because it's kind of taller than it is wide. So if you look at all these, there's all these different pieces that come together. So every single one of them has a center. So it's centered right in the middle here. So the way this is written is as if the center were right at the origin. So notice they both have a center. And then they have 4 other points. So instead of having like a radius that goes all the way around like a circle does, we've got these 4 different points that are super important to the graph. So you've got 2 vertices, and the vertices are always on the larger of the 2 lines. So this is the farther distance. Take you to the vertex here, and then with this one, the vertical one, the vertices go up and down like this. And then the shorter of the 2 distances will take you to what we call the co-vertices. So this one, you go up to the co-vertex, down to the co-vertex, and then with the vertical one, we go left to the co-vertex and right to the co-vertex. And so we call the larger of the 2 distances the major axis, so it's horizontal in this one, and the major axis is vertical in this one, and then vice versa for the minor axis, that's the smaller of the 2. So this, the minor axis is vertical in the horizontal one, and it is horizontal in the vertical one. So just some vocabulary to keep in mind while we're going through. I'm going to give you guys a rundown of what these equations will look like, and then we're going to create some equations. Okay, so this first one, this just like the picture showed, these ones are centered at the origin. Okay, so this one, when you've got x squared, y squared, and then a squared, b squared, when it is oriented like this, this is horizontal. So first note that I want to make right here, see the a squared here and here. The reason that we even care why the x comes first here and the y comes here is the a is always going to be larger than b. So that's very, very important here. So here, if the larger of the 2 distances is under the x, then we call it horizontal. If the larger of these 2 numbers is under the y, then we call it vertical. That's the only way to know the difference between those 2. All right, so the length of the major axis, we call that 2a units. So remember, a is the larger of the 2 distances, so for this one, the major axis is 2a units long. So same thing here. So with this one, the major axis goes horizontally. With this one, the major axis goes vertically. And then with this one, the minor axis, remember, b is the smaller of the 2 values, so the minor axis is 2b units for both of these. All right, and then our vertices, so the way that this works is we start kind of right at the center, right at the origin like this, and then my vertices, I go a units to the left and a units to the right. So my vertices are now going to be at negative a, 0, and positive a, 0. So I go a units left, a units right, but I don't go up or down at all, which is why my y values are still 0. And then my co-vertices, I go up and down, b units. So here my x value stays at 0, but I go down b units. And then again, my x value stays at 0, but I go up b units. So this one's horizontal, so remember it's more like this. It's wider than it is tall, and this one is taller than it is wide. So this one, the vertices go up and down this time. So my vertices, I go down to negative a and up to positive a. And then for the co-vertices, I go left and right for those. So I go b units to the left and b units to the right. Okay, so those are the setups. They're going to seem a little bit strange. Let's write an equation, see how we feel about this. So if my vertices are at 0, 5, and 0, -5, and then co-vertices, it's a really, really good idea to kind of sketch this out so you know exactly what all the pieces look like. So sketch it out. We've got co-vertices at 5. I'm sorry, whoops, wrong way. So my co-vertices are at 0, 5. Sorry about that. Right there. And right there, and then my co-vertices are at -3, 0, and then +3, 0. Please, sorry, ignore that point right there. So my ellipse looks like this. I am much better at drawing ellipses because they don't have to be circular. They're supposed to be lopsided. So that's what our ellipse looks like. It's centered at the origin, so it's going to be just like one of these. I don't have to move left, right, up, or down yet. Now this one is definitely a vertical, and so our larger of the two distances is going to be under the y. So we start with y squared over something, x squared over something equals 1. And we'll get to that something right now. So the number of units that I'm going up and down is 5. All right, so 5 represents a, so I do 5 squared. So this would be 25. So remember, y represents an up and down movement. I'm going up and down 5 units. It's kind of like a radius idea. You know, with the radius, you had to take the square root. So you're kind of doing the same thing here. And then x takes me left and right. So I'm going left 3 units, right 3 units. So this kind of, you can consider it to be like a radius. I've always called it like the horizontal radius. You go 3 units left and right. So since I'm going 3 units left and right, 3 squared would be 9. So this would be your equation for that particular ellipse. I know they seem really weird. You will get used to them, I promise. Next thing we're going to do is translate these, left, right, up, and down. So you'll see this is the horizontal one. So remember, we are still keeping in mind here, very important, that that value of A is going to be greater than the value of B, because A is going to lead us to the major axis, B is going to lead us to the minor axis. So this one, with the larger number under the X, means it's horizontal. It means it's wider than it is tall. And then this one, with the larger axis under Y, that makes this vertical, means it's taller than it is wide. So this is going to be your vertical ellipse. So all of these things are actually exactly the same except for the center and therefore the co-vertices. So the major axis is still 2a units and the minor axis is still 2b units. So I should say units in there. Okay, so that part is not changing. The part that is very important, so this part, I should mention this. The center of these is h comma k. So just like the circle, you go, h units either left or right, k units either up or down. So here's the part that gets a little weird, the vertices. All right, so I want you to picture that like this point right here is hk. And this point right here is hk. So for the vertices, I'm starting at hk, but then I'm going to the left a units and I'm going to the right a units. All right, so I'm starting at h and then going either, so no comma there, going either left or right a units, but my y value is staying at k. Okay, and then this one, I start at hk and I go either up or down a units. So my value of h doesn't change, and then I start at k and go either up or down a units. This will all get easier as we get some practice with it. Co-vertices are right here and right here. So I stay at my value of h, but then I go up and down b units. So I stay at the value of h for x, and then I start at k and go either up or down b units, because b is my minor axis. And then here, the smaller of the two axes takes me left and right to my co-vertices. So it's my x value that's either going to the right or to the left, b units, but k is staying the same. Okay, so we just need some practice with that so that it gets a little bit more familiar. So let's look at an example. So writing an equation for the ellipse, so like I said, sketching this out, especially with these ones, because these ones aren't going to be centered at the origin. It's a really, really good idea to sketch these out. Okay, so -6, -2. It's right there. and then positive 4, negative 2. It's right there. Co-vertices at negative 1, negative 4, and negative 1, 0. Would be right there. Okay, so this is my ellipse. It's definitely a horizontal ellipse. So let me write out that equation. Okay, so this is the equation for a horizontal ellipse. I just want to fill in all of the details here. So first thing you need to do is find the center. All right, so this right here, that's your major axis, the horizontal one. And then this is your minor axis, which is the vertical one. So your center is going to be right in the middle here. So if you've drawn it accurately, you should be able to figure out exactly where the center is, and it's kind of in the middle of these 4 points that you just plotted. That's why plotting it is so, so important. So the center. All right, so this x value right here is the x coordinate of the center, and it's negative 1. Notice it's the same x coordinate as these guys have. So this is negative 1, and then the y value is negative 2. It's the same y value that these two have. So you can see that corresponding spot right there. So that is our center, is negative 1, negative 2. So that is your h comma k. So negative 1 is going to get subbed in here. Negative 2 is going to get subbed in here. And then we need to figure out what a is and what b is. So a is going to be this distance right here. Okay, so that distance, because this is 2a, so let's see how long this is. So the major axis is how many units wide? Let's see, it goes from negative 6 to positive 4, so that is 10 units wide. So this is 10 units wide. But remember, the major axis is supposed to be 2 times a, so that means that a is equal to 5. All right, so we can start with that. And then the minor axis, goes up and down. It goes from a y value of negative 4 up to a y value of 0. So that is 4 units from point to point. So the minor axis is 4 units. And remember, according to our formula, the minor axis is 2 times b. So that means that b is 2. All right, so we got a, b, h, and k. That can all just get plugged into this formula right here. So we have x minus h, so h is a negative 1. So minus negative 1 over, and then a squared. So a is 5. 5 squared is 25 plus, and then y minus negative 2. So it changes to plus 2 squared over b squared. So 2 squared is 4. And then it's always equal 1. You'll never see anything but 1 on the other side of that equation with ellipses. So let me walk you through exactly what this means and how it translates back to this graph. So this negative 1, negative 2 would be the center of your graph right there. Negative 1, negative 2. And then this 25 means if I take the square root of that, that's how many units I go until I hit my vertices. So 5 units to my vertices. So from here I go 1, 2, 3, 4, 5 units to the right, and 1, 2, 3, 4, 5 units to the left, and I hit my vertices. This 4, if I take the square root of that, I get 2. That means I'm going 2 units from the center until I hit my co-vertices. So here's my center. I go up 2 units, I go down 2 units, and I hit the coordinates of my co-vertices. So in our next video, we're going to do like the basics of hyperbolas, and then the video after that, we're going to graph both the ellipses and the hyperbolas together.